if we have d square plus a square is equal to 0. Very simple. I just show you how to write. So put d is equal to m. Our auxiliary equation is m square plus a square is equal to 0. So m is equal to plus minus iota a. Is this okay? Because m square is equal to minus of a square, minus of, so m is equal to under root of a. Root of a is plus minus iota a. So our solution is plus minus iota a. It means 0 plus minus. So alpha is 0 and beta is a. So our complementary function is equal to e to the power alpha means 0x c1 cos beta x plus c2 sine beta x. Beta means a. So e to the power 0 is 1. So our complementary function is c1 cos ax plus c2 sin ax. Means solution of this equation, if right hand side is 0, is equal to c1 cos ax plus c2 sin ax. That is the solution. This I just show you how to write the complementary function for imaginary. Similarly, if roots are repeat, c1 plus c2x, previously we discussed in the cases. Next is very important, how to find particular integral. Particular integral we have to find with right hand side of the given equation. Right hand side is always is the function of x. If it is the function of x, how we can find right hand side of solve? So next step is how to find the particular integral. Similarly, like the complementary function, we have for particular integral we have cases, different cases. First, our given equation is f d function of d y is equal to x. Now we have to solve this. So we have to rewrite y is equal to 1 upon f d into x. Okay. First, for particular integral, we write our equation in the form of 1 upon f d into x. Now we discuss the cases for particular integral. Case 1, when our this function in exponential e to the power ax, any exponential form, then that's very simple. You substitute this d equal to a, means our particular integral is f of a or e to the power ax comes in front. So pi is equal to e to the power ax upon f of a, where f of a is not becomes to 0. In case of failure, if f of a gives 0, then we don't go in this process, means d is not replacing with a, then we go for the other process. At the last, I will give the general solution of particular integral. That case will be applied for every case of failure. So first step, if exponential function, put d is equal to a. If we have factor here, which part gives d, which part gives not equal to 0, you put d replace with a. If any part gives 0, then you don't replace, we go for the other process. For example, if our equation is d square plus a square e to the power 2 x. Okay, so what is the pi of this? Pi of this, d replace with 2. So e to the power 2x upon 4 plus a square. So our answer of pi is just replace d with a. A is your 2. So d replace with 2. Just very simple example without case of failure. Second case we discuss, when this given function in form of sine or cosine. Given function is sine ax plus b or cos of ax plus b. If given function of x right hand side is in form of sine or cosine, You just remember, substitute d square is equal to minus of a square. See and concentrate very carefully. We don't replace d equal to a. Here we replace only the value of d square. You replace with minus of a square. If you don't have d square, then you won't able to replace d with a. Just d square replace with minus of a square. So if our equation is 1 upon f of d square sine ax plus b, then answer becomes, this becomes 1 upon d square replaced with minus of a square. So our answer becomes 1 upon f minus a square and sine of ax plus of b. So this is our particular integral. So in further we can see how we replace. For example, if we have same 1 upon d square plus 4 sine of x, just sine of x, it means our a is 1. So d square replaced with minus of 1 square is minus of 1 square is minus of 1, not plus of 1. You cannot squaring minus sign. Minus sign is outside. Minus a square means minus of 1 square is minus of 1. So our answer becomes 1 upon minus 1 plus 4 sine x. So answer becomes sine x by 3. So a particular integral pi of this case is equal to sine x by 3. Clear? Just very simple example, so you can go through how to replace d square with many students I saw that they will replace d with a or d square with a square. No, d square replaced with minus of a square. Minus sign should be there and d cannot be replaced. In this case, d equal to a replaced in the case 1 where function is in exponential form. Next case of third. In third case, if given function, case third, if given function of x in the x power of x, okay, n is positive integer. N is the positive integer. If our given right hand side in the function of x and power of x, then what is our process? In this case, we have to, whatever our equation 1 upon fd x to the power n, we have to take out the lowest degree term from fd outside. So make first term is unity, because here we use the binomial expansion. You always study previous levels binomial expansion. I will give you the, I will explain this with one example. If our equation is 1 upon same d square plus 4x square. So what? We have to take 4 outside. So 1 plus d by 2 square we can write, or we can write d square by 4. This comes up, so 1 by 4, 1 plus d square by 4 inverse x square. Means our function we have to come like this. Hence we have to apply the binomial expansion. I will give you the binomial expansion. 1 plus x to the power minus 1 is 1 minus x plus x square, x cube, and so on. If this function is 1 minus x to the power minus 1 inverse, then 1 plus x square plus x cube, means all signs are plus. If both are minus. If one is plus, one is minus, plus minus plus minus. Similarly, if 1 plus x to the power minus 2 whole square, then 1 minus 2x plus 3x square minus and so on, 4x cube and so on. Similarly, if this case is there, minus of x minus 2, then 1, all signs are plus, 1 plus 2x. So our expansion for this is equal to 1 up to what level? Where we finish this function. D means d by dx, means we have to differentiate. If somewhere comes 1 by d, 1 by d means reverse of differentiation, that is integral. 1 by d means integral with respect to x, d means differentiate with respect to x. So when we expand this function, 1 by 4, 1 minus d square by 4 plus d square by 4 whole square. No more need, because our function is x square. When we put inside this term, 1 into x square gives x square minus 1 by 4. D square means 2 times differentiate this function. So when we differentiate one time, d by dx of x square is 2x, and one more times d by dx of 2x gives only 2. So this function finish here is 1 by 4 x square minus 2 by 4. 2 by 4 means 1 by 2. So our particular integral is 1 by 4 x square minus 1 by 2. That's all in case of if power of x is given in right hand side. So you should just arrange in binomial expansion. Expansion is there. You expand up to what term where this will be finished. With the, because for next we don't have 4 times differentiate x. So when we first time gives 2x, second time gives 2 constant only, third times it becomes 0. So this terms becomes 0. Our answer will give with this 2 terms only. So this is the case third, when function is in power of. Next is the fourth one. Fourth one we will discuss. Yes, just now I will discuss because I have some more time. I want to give all the cases, then in my next video we can see how to solve this linear differential equation with higher. I will give you one whole questions. So case 4. Fourth is if our given function x is e to the power ax into v, means v is any function of x, means this function of x one more time multiply with exponential function. Then what is the process? Our first we write y is equal to 1 upon fd e to the power ax into v. Next replace d at the place d plus a. Replace d is equal to d plus a. This a should be. So our new function becomes e to the power ax, come outside, 1 upon f of d plus a into v. Now this v is function of x. What type of function is this? We have to solve this 1 upon d plus a with this. Okay. For example, if our equation same 1 upon d square plus 4 e to the power x into sine x. See, function of e to the power x into v is sine x. Then d replace with d plus a. D replace with d plus a means d, a is 1. So 1 upon d plus 1 whole square.